Hello. I will be talk today about as you already know, about the COVID-19 and about the South Korea. First, I will introduce a bit about why I choose the South Korea and how we can find the data, how we can find the real data which are really reliable, and how we can find the data which we can use in our analysis. Then I will show you how to do the graphs using Python and Jupyter. And in the end, you will see the graphs and you can do it yourself, because I will share with you the repo where you can see the whole code. I will do generate the semi-live coding, because I will show you step by step how the things are changing. But I won't type the code because I think it's not very good version of doing the presentation. Okay, and yeah, I was yesterday told to first introduce myself. Okay, so you know already my name and surname. So I'm Izabella Jaworska, if somebody doesn't notice it on chat yet. I work in Lotland. I work in the BI team, and I like to play bridge, as you can see the cards in my background. And I studied maths, and I want to share you two photos. 1 second. I will need to share the screen in either way, so let's do it. Not this screen. 1 second. No. First, and one more time. I need to share this one. Okay. Yeah. And I want to show you two photos. I studied math, and during my studies, they were trying to convince me for 5 years that this object and this object are the same object. When I finally believed them, they finally gave me the diploma and told me that I can tell that I'm the mathematician. So I'm a bit strange person, because after 5 years of studying maths, you cannot be not strange person. So because of it, I also find the peace in data. I found when I look at the data and I know that I have the data, I feel calm. And that's why I made the analysis about the COVID-19, because I was looking if there are some interesting things. I was looking if there are some optimistic things. And I found the two quite optimistic cases. One was the Singapore, and the second one was the South Korea. The Singapore, okay, this is the next thing. I will make my screen bigger. Is everybody seeing my screen? Great.
Yes.
Great. Okay. I will, one more thing. I will let you ask all of the questions whichever you want after I will finish the presentation. So to make it clear, particularly that there's quite a lot of us. And so, okay. So first country which I was interested was the Singapore, because they had not a lot of the cases, new cases, and they had nearly no deaths. But I discovered that, okay, we don't have a lot of the data about the Singapore. So even though they are a very optimistic country because they have everything under control, I decided to look deeper in the South Korea, which has a lot of data because they made really, really big amount of tests. They tested over 300,000 of people. And one thing which I want to show you on the in the beginning is that you should be very careful on whatever graphs and data you look about the COVID-19, because it's very easy to manipulate the data and show not true things. And I will show you probably you already noticed some dramatic newspaper titles, and usually the information which is inside is not so dramatic as the titles. For example, if you look at this graph, which is the graph of the death rate in South Korea, you can notice that it was increasing in last days. and that it's really, really fast increasing. But if you look on the y-axis, you will notice that the steps are really small, and that all of the data are below between 0 and 1.2%. So instead of showing this pessimistic graph, we can show this graph, which would be very optimistic, that nearly everybody in South Korea is still alive. As you can see on the violet graph, that the death rate is it should have different description. The violet line, which is showing the survival rate, is showing that nearly all of the people who were COVID-19 positive in South Korea are still alive. So you should be careful when you are looking at the data, because it's very easy to read them not properly. Okay, I will now show you how you can find the data about the South Korea. And the proper version of the data, the best version, is the government site, which we have here. And let's hope that, yes, today it's open smoothly. And on this site, every day they're attaching the new information about the number of cases and about the total, the number of confirmed cases. And you can see that they are over 350,000 of tests now. And you can also find here the information about the every provision. You can find the information about the, and about, for example, connections, because South Korea is doing really amazing job in tracking all of the cases. They know how the 80% of people become COVID-19 positive, so how they catch the illness, who they met, where they met, and with who they met after. They are doing a lot of the tests, and they are doing them not only in the hospitals, but also you can do the drive-through test or walk-through test. So if you want to go, for example, to the shop, before you enter the shop, you have the COVID-19 test. You wait 10 minutes for the result, and if your result is negative, you are allowed to go to the shop. If your result is positive, you are told to go to home and self-isolate. You can see now the table, which I found, for example, very interesting. It's the table about the demographic structure in South Korea. As you see, they really made the test to everybody who could met the COVID-19 virus. So their data are really good, because we know not only about the people who have the symptoms and who need the medical care, but we know about all of the people who are COVID-19 positive. And you can see that one of the biggest group here which is COVID-19 positive is the group between 20 and 20 years old. But what you can find also, if you look deeper on this data, this is the group which has really mild conditions, and they usually are really okay after. So it's just like the cold for them. So I found that this data are really, really interesting, and I decided that I would like to look on them deeper. And that's why I decided that I need them in some nicer form than this one, because you cannot analyze the data which are in some text. You need some data set, which is some CSV file or something like that. And I decided to look for it. I used the site which is called Kaggle. And this is generally the data science competition site, but you can also find quite interesting data sets here. So if we type novel coronavirus data set, as you can see quite often, I look for it, but I probably will find it in different way. You can find in this version a lot of the data sets, and I think this one is the one which I used. Yeah. So you can find here the novel coronavirus 2019 dataset, and you can just download it. What I will do, because I prepared the presentation 3 days ago, and as you can imagine, the situation is changing quite fast. So let's use the up-to-date data. So I downloaded the file, I just unpack it, and I will need only one file, which is called COVID-19 data. I will copy it to my folder. I'm not sure which file I have open. So I copied it here to the data folder. And because I'm not sure which file, I copied it also here. Okay, now I'm prepared with the new data set. As if you want to download it, you can also do it whenever you want. I'm just curious how I can use the chat. Okay, no. Okay, this is the link to Kaggle if somebody would like to use the data after the meeting. And I will send you also the second link. This is, oops, not this one. This. Okay. I need to, I'm sorry for the mess in my computer, but I wanted to use the different computer and something had broke just before the meeting. Okay, so I sent you the link to the repository where you will find the also the data which I used earlier to prepare the presentation, and the Jupyter notebook file which I will use today. Okay, so first, okay, maybe 2 words about the Jupyter and Python, first of all. The whole presentation will be done in Python, the whole graphs, and I will use the Jupyter notebook to do it. It's just the tool which lets you use the Python easily. And I'm using the Anaconda navigator to install the Python and then use the Python. So if you install Anaconda on your computer and open it, you have the screen like I have now, and you just click launch to open the Jupyter. Then you can click and open the new notebook, and you can type, and it's working. So now we already downloaded our data, and one more thing about our data set. Our data, which I downloaded a few seconds ago, is the CSV file, as you can notice. I don't have Excel on this computer, so it opened just as the normal text file. And we also show it here. Okay, this is the end result, which you will see, or which we produce during this meeting. So it will be the graph about the South Korea, and it will be showing the number of confirmed cases, the number of deaths, and the death rate calculated in 2 different ways, which I will introduce later. And to do it, I will use mostly 2 packages. First of them is pandas, which let me to transfer the data and to prepare them for the graphs and everything else. It's the really amazing library whenever you need to do something with data. And the second one is Matplotlib. This is the library to create the graphs. So I need to upload. Okay. Open today, I hope. Okay, so I need to import first the libraries which I need to use. So I import the pandas and I name it as PD. I import the matplotlib and some party graphing from the matplotlib, which is called pyplot, which I renamed as PLT. Then I import the data, this which I just downloaded from the Kaggle site. And we can see how the data looks like by using the head function. So we see that that the data set has the information divided by the country and province, and the data for every day since the start of the coronavirus. You can also in Kaggle find the whole description about the data set. So you can find exactly how this data set was built, how to use it, and a lot of other details. It generates the data set which was built mostly by Johns Hopkins University. So this, which you probably saw the map built by them. I think it's the most popular one in use. Okay. So let's come back to our Jupyter notebook. So we are interested in South Korea today. So let's filter data only for South Korea. You see here that we filter for South Korea. We can now see that our data really have the South Korea as the country region. And in most cases, you have data split by the province and state. In South Korea case, we don't know anything about the province state, so we don't need to group the data by the province state. We could just use them as they are now. But because you maybe would like to use this code after the meeting, I decided to show how I would work with the different country divided by the state. So here is the group by function, which let us to group the data by the observation date and by the country for which we want to do the graphs. We have two columns which we are interested. There are confirmed cases, deaths, and recovered. So we sum them from every region. Okay, so we run this function and we can see that now we have observation date, country, region, and number of confirmed deaths and recovered. Much easier data than a few seconds ago. And the Python has some, this is generated data frame in Python. And this data frame after the group by has the index. So you can see probably that these two columns are bold. And we don't like to have index because it's easier to work with data which doesn't have it. So we will remove the index. So now you see that all of the, I hope you see the difference between first and second table. So in second, the South Korea and the date are not bolded anymore. Okay, so let's try with, as we have already the data, let's try to do the graph. It's, as you can see, yes. We need to do some small change because it seems that it's the notebook which I already ran, and I don't want to use the things which were not uploaded and done yet. So, okay. I firstly rerun the things from which I already told you how it works. And now I rerun the simple graph. So whenever you want to create the graph, you just tell that you want some figure and that you want the sum of the axes. And you just wrote that you want, for example, the bar or the line. In our case, we want to create the bar graph. So you wrote that you want to have the bar graph. You write what you want to see on the x-axis. So we want the observation rate, and what is we want to see in the bars. So in this case, the number of confirmed and number of deaths. And as you see, we already have the graph, but something with our x-axis is completely wrong. It's completely not visible. So we want to fix it. To do it, we first of all need to change the format of the data, because as you can see, the observation date is in the American format, and we have first the month and then the date, and it's not recognized by Python as the date. We need to have the dates on the x-axis. So to do it, we will need the new library. It's called datetime. So I imported it here, and I use the function strip time from this library. I provided the format of the data which we currently have, and I told it to change it to the really date, and as you can see it. And now we import the one additional thing from the one additional library, or rather one additional part from the Matplotlib library. It's called mdates, and thanks of it, our x-axis will look much nicer, or maybe not. I didn't run the code. Yes, so as you see, it's very important to change the the string to the days, because if not, it won't work. So now you can see that it looks better because we have at least some dates, but they are still overlapping each other. So to avoid this thing, we rotate them by 45 degrees. And now we have x-axis, which looks much nicer. And first of all, it's readable. But when you look at this graph, you still don't see what is the blue bars and what are the orange bars and what's going on, and generally what is on the graph. So we need some Python legend. And in Python, it's very, very simple to add. You just tell Python that you want to set the X label to something, Y label to something, and to add the title. And we also add the legend here. So let's do it. And now it's much better. We have the name of South Korea, we have the number of cases, we have the name of the x-axis, which are dates. So I show you area that we want to see on the graph, the death rates. So we need to add 2 lines. So let's come back here. So I will calculate the death rate in 2 different ways. One of them is the number of deaths divided by the number of all of the cases, so all of the confirmed. And the second is the number of deaths divided by the closed cases, so divided by the deaths plus recovered. So we are excluding the active cases because we still don't know what will be the outcome from the active cases. So I renamed the data set to have the shorter name. Nothing magical is going here. Then I will need the smart function, which is called shift, because as you could notice already, I haven't mentioned it earlier, in our data set, and it's not visible here. In our data set, the number of confirmed cases is increasing with when the dates are increasing. It's showing not the confirmed cases for the date, it's showing the confirmed cases till the date. We need the number of confirmed cases for the particular day if you want to calculate the death rate. So to do it, we will use the shift function. Okay, so we use the shift function, which let us just get the numbers from the one day before. It's moving, it's exactly shifting the data set for the one row. I commented here the version which you would need in case if you are doing the same operation and you have more than one country, because then you need to shift it for one row, but you don't want to have the last number for China as the first number for Korea or something like that. So to avoid it, you need to tell it to treat every country separately. So we are calculating the number of deaths yesterday and number of confirmed cases yesterday, and thanks of it, we can calculate the number of confirmed and number of deaths per day. And we are calculating the death rates for every day. So I can run it and I can show you how the data set is looking now. So you see that for the first day, we don't have the data, but it's not a big issue. And for the next days, we have calculated the death rates, we have calculated the confirmed cases per day and the deaths per day. So we are now prepared to add our lines. And adding the lines is the same simple operation as earlier with adding the bars. So we generate what we want to have on x-axis, on what we want to have in the line, and we name the line to have it nicely in the legend. And we now have the graph, which is not showing the lines. So again, something went wrong. The thing which is wrong is that we added the lines which are from 0 to 1 to the graph which has on the y-axis the number from 0 to 10,000. So we are not able to see the lines. They are existing on the graph, but they are somewhere between here and here, so not possible to see by our eyes. And to fix it, we add the additional axis, the right axis, and on this axis we have the smaller values. So we now add the new axis, and the Python is so smart that we don't need to tell it that how we do it. How we want to have the, okay. If we want to have the numbers from 0 to 0.5 or anything like that, it will automatically adjust the axis. Okay, so now you can see that we still have two issues with the graph. Our legends have disappeared somewhere. And if I will write it as it was earlier, it still is not showing properly because it's showing only the legend for the lines. It's not showing the legend for the bars. So we want to fix it. And the second thing which is wrong are the colors, because we have blue line on blue bars. So generally really hard to see where the line is here. And first I will fix the issue with legend. And generally, I think that nobody remembers how to do it. So whenever you need to do some very tricky things with Matplotlib, you either can use the documentation of Matplotlib, which is quite good, or you can just look for the things in Stack Overflow, what I did when I needed to find how to fix the legend. And now you see that the legend is working fine. So we need to do something with the colors of the lines. And generally, of course, you can use in Python any tool to set the colors, and you can just type the RGB version of the color and it's not a problem. Or you can use the library, which is called Bokeh, and which is letting you to have the nice set of colors. So you have the link to the site is like that. And you can see on the side that there are many different palettes which you can use. So most of them is really nice and useful. And for today's presentation, I will use two of them. One is Viridis and the second is Inferno. So I will use this one and I will use this one. If you type in Python, as I did, something like that, it will just, it will just create you the 4 colors from this palette. So the parameter is telling how many colors we need. So this will create 6 colors. So I use it to create 2 different palettes, one for the bars and second for the lines. And I added the parameter for the bars and for the lines to set the colors. So now you see that we have distinguished colors and that we can read what's going on our graphs. We can interpret the bars and the lines which are on it. And you can notice that the graph which I showed earlier had the additional thing. It had this lines, the helping lines, which are letting you to easier read the numbers. And we don't have it here. It is because I use different style in Python to do it. This is again the nice thing in Python. You don't need to tell everything separately. It's letting you to just upload some pre-designed things. And here you have the next slide, which is showing the different styles which are possible for the graphs. So you can easily just choose the style which you want. And my graph, which I showed you in the beginning, was using the seaborn white grid, this one. And the graph which we will build today, we use the BMH style, so this one. So let's set the style. So we are just telling the Python that we want to use the style BMH. And we don't need to do anything other special. We just create the graph. And 1 second, because I used one additional trick. Yes, so we are just telling Python to run the graph, and yes, it added the helping lines, but the thing is that it added different helping lines for the left and for the right axis. So probably there is a smarter way of fixing it. I just used the very easy one. Okay, I know that there is a smarter way, because we can tell Python exactly where we want to have this fix on the Y axis, but I use now the simple solution. I just use the set the limit for the axis to some similar number, let's say. So I know that if we have 50%, the ticks will be every 10%, and if we have 10,000, the ticks will be every 2,000. So if we set the limits like that, the lines will be in the same places. So this is the simple solution. The better solution is to tell exactly where the ticks should be. So now we have the graph where we can easily read the number of confirmed cases, the number of deaths, and then death rate for closed cases and death rate for the for all of the cases. As you can see, the death rate for all of the cases is really, really small. This is the same as I showed earlier the first graph and the second graph. As you can see, these two graphs which I added are just using some different style. It's called solarized light 2. So that's why they have this strange yellow background. I use different possible styles to just show you the possible things which you can use. So, okay. So it's generally everything what I wanted to show you today. You can download the Jupyter notebook from the repository to which I sent you the link. And you can try yourself to build the things. You can also notice one additional thing on the graphs. Here on my first graph, I use the days from the patient number 100, what is quite useful thing when you try to compare different countries. And here we build the graph with the normal dates. So you can see that the number of dates which it took South Korea to grow from 0 patient to, let's say, 500 was really, really long period. It's because they started to testing everybody from the beginning. And what happened next was the patient number 31. I think that it is quite interesting story because we've seen then the very high increase in number of cases. And it was just because the patient number 31 was quite well recognized person and he was the church leader. So when he did the big meeting, a lot of the people caught the illness. And that's why we saw the very big increase. But as we see, the South Korea again took it under control, and now the increase is very, very small. And if you look on their government side, you can see that the increase is mostly from imported cases, that they newly don't have the new cases on their own. So I think that the South Korea story is interesting because it shows that it's possible to control it. And I hope that we soon will be able to tell it about other countries that we also control it and everything is okay. Okay, it's everything from me. I hope you like it and I hope that you will try to build something on yourself. You can also find quite interesting courses, for example, on Coursera. Just a few minutes before the meeting, I got the email about them, so feel free to use it.